Alright, the answers are -2, -1, -1.5, and -4.3. If you have any of those right, come up here and claim it. Show me what you had right. Warm-up quiz. Answers should be 2, -5, -1, and then 2. If you wrote -1 twice, I'll count it, and if you wrote 2 twice, I'll still count that. But you only have to write it once. Homework check. It is 10 out of 19. 53%. Now, it's higher than 50, so you can only choose one number. If you have credit for your homework, choose one number from 1 to 20. The winning numbers are 4, 12, 14, 16, and 20. Multiple choice, bring the block letter only. The answer for this one should be B, -2, -4. Here are the homework answers. The first couple are kind of blurry. I guess the phone didn't focus in. But it should be ±1, ±2, ±3, and ±6 for number 1. And you must have them all on there to get the point for the homework. Each problem is 1 point each. Number 2, ±1, ±5. Three is ±1 and ±4.
How about ±2?
Yeah, you're right. It is ±2 as well. And 4, you'll have ±1, 2, 3, 6, 1/3, and 2/3. I'm just not going to say plus or minus all the way through. It's written on the screen. Number 5, you're going to have ±1, 2, 4, 8, a half, and then a fourth. The rest of these canceled out. 1, 2, 4, 8, half, and a fourth. For number 6, you're going to have ±1, 3, 9, a half, 3/2, 9/2, and 1/3. If you express this as 4.5 and this is 1.5, it would be fine too. 1/6 is back here. I didn't circle that one either, so that one counts. On number 7, you should have ±1, 2, 4, 8, and then a half. Notice we already have a 2, a 1, and a 4, so that's why these were taken out.
I thought that was just a regular count, not a 10x.
I remember I changed that on the homework. Did it not show up on yours?
Not on the picture.
Number 8, you should have ±1, a half, and then a fourth. And on number 9, you should have ±1, 2, 3, 4, 6, and 12. Alright, and then the last one, number 10, you should have ±1, 2, 3, 4, 6, 12, and then 1/5, 2/5, 3/5, 4/5, 6/5, and then 12/5. Here's example 1. You'll have a test tomorrow that covers the graphs that we did for quadratic equations, and there might be a couple of simple ones of this one on here as well. There won't be anything like the where you have a leading number of 24 and a back number of 36. That would be probably 40-some numbers you'd have to list. We're not doing that. yet, but the test will have maybe like a quadratic equation where you find all the possible roots by using the rational root theorem, but that's as far as it'll go for the test tomorrow. Alright, so here's an example for the rational root theorem. We're going to have to go where first and do what?
You go to the back number, right?
Back number first, so it's a -8. The sign really doesn't matter since you do plus or minus. And what do we have to find concerning -8?
You find what goes into it.
Okay, so what numbers go into 8? 1, 2, 4, and 8. Alright, so once we have those factors, where do we go? The first number. So we will go to the first one. And what do we need from the first one?
1, 2, 4.
We'll need 1.
Or 2. It'd be 2 and 4, right?
Yeah, we just need the 2 and 4 because when you divide by 1, you're just left with what's out here. So we don't even fool with it. We don't write all that over 1. Because then you end up having to rewrite it again for just really no reason at all. Where do we go after we have found all the factors of 8? Oh, we already did it, so we went to 2 and 4. So now what do we do with the 2 and 4? Make them into fractions. So how many more times am I going to have to write out this line here?
Twice.
At least twice. So we're going to have to do plus or minus 1, and then 2, 4, and 8. And then we'll do it again. 1, 2, 4, and then 8. So what am I going to do on this line?
You're going to put a bunch of 2s in it.
Yeah, we're going to go through and divide by 2. And what am I dividing by on the last line here? 4. Alright, so we'll divide by 4. Now, is there anything that can cancel out?
2, 2. Or 2 over 2. 2 over 2.
Yeah, 2 over 2 is a 1. We already have it.
4 over 2.
4 over 2.
8 over 2.
8 over 2.
8 over 4.
4 over 4.
2 over 4.
2 over 4.
And 8 over 4.
8 over 4. So that's it. That'll leave us with all of the possible roots of that equation. And remember, they are possible. It doesn't mean they are. The next thing we'll do next week is figure out which ones are actually, if any, roots of the equation. Alright, for this one, we're going to have to find the factors of 6, so that's going to be plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. So for the factors of 5, we're going to end up with 1 and 5, but we only need the 5. So we can leave that first row the way it is, and then go back and divide everything by 5. So if we do that division by 5, is there anything that's going to cancel out?
No.
No, so you must have all of these for your answers. Answer to this one is 14. Answer is 0. This one goes to the first 7. The first 8 to the first 8 people. Here's another practice. F of x equals 6x squared minus 5x plus 8. Alright, you got to start with your factors of this one, so that's going to be plus or minus 1, 2, and 4, and then 8. So you need the factors of 6, excluding 1, that's going to be 2, 3, and 6. So we're going to have this 3 more times.
Oh man, I didn't do 6. I didn't either. I didn't.
Uh-oh, we already figured out a problem?
Yeah.
Well, that'll eliminate a bunch. So we need this second row here. And there they are, through magic. So now we go back through and divide this one by 2, and we'll divide this one by 3, this one by 6. Alright, so let's start canceling out stuff that we don't need. 2 over 2, that's a 1, don't need that. That's a 2, don't need it. And that's a 4. The second row is good because you're dividing by 3 and it won't cancel anything out. We already have a 1/3, so that's gone. And we have a 2/3, that's gone. And we have a 4/3, so that's gone. You should have what's on the screen. Answer is 21. Answer is -53. Alright, to the first 8. First 8. Answer to this should be 96. Last problem of the day.
-2, not -9.
What is it? Yeah, 13.